Let's move forward and discuss a very famous adsorption isotherm, that is Friedrich adsorption isotherm. I hope this adsorption isotherm is clear to all of you now. It's nothing, just a graph between x by m and p at a constant temperature. Now see, if we take a system, let me discuss in detail first, and for example it's at pressure P1 and its temperature is T1. Let's take another system similar to this and its temperature is T2, and let's take a third system over here. Similarly, this is a solid surface and its temperature is T3. Now let us focus on this system first. At this P1, this pressure, some molecules will adsorb and some will try to dissolve. After some time there will be a state of dynamic equilibrium. I hope you remember that. And now let's denote x. X is the amount of substance which is dissolved on this surface at this equilibrium. And now let's increase the pressure for this system, keeping temperature same. Now let's take this system. Now consider this system as first system. Its temperature is T1 and now pressure is P2. Obviously more particles will dissolve, and after some time this desorption rate will be equal to the adsorption rate, so there will be a dynamic equilibrium. But the amount of particles that are adsorbed at this pressure, let's take this x2, this x2 will be greater than x1. That means let's take this P1 and this as P2. This is x1 by m at first equilibrium, for example it's this point, and at this P2 x2 will be here because it's greater than x1. So let's take this point here and join this with P2, and as we go on increasing, this will be P3, and similarly corresponding to that it will be x3 by m. If we join these points we will get a curve, and that curve is known as adsorption isotherm. I hope you remember this. I just try to remind it. Now in the last video I have made a curve like this and this. Now I think it will be more easy to understand. This one is for system 1, this one is for system 2, and this one is for system 3. First we draw this graph, forget about this and this, we draw this graph. This was for this system which was at T1, so we get a curve like this. Now forget this and this, take this as your system. It was a system like this, the system at T2, so varying its pressure we get a curve like this. Obviously this is a graph between P x by m. Similarly forget this and this, take this was a system where temperature was T3. Now this is the equilibrium concentration corresponding x3 for system 3, which was at temperature T3. It is more as compared to this x2. x3 is the amount of substance which is adsorbed on the surface for system T3 at equilibrium. Similarly, this x2, it is the amount of substance which is adsorbed on this surface when temperature was T2. And similarly, this x1, this is for the system T1. Now this x1 is less than x2, which is less than x3. That means this T1 should be greater, because at higher temperature the amount of adsorption will be less. This T2 will be greater than this T3, because the amount of substance adsorbed at this T2 is less than the amount which is adsorbed at this T3. So this type of graph, this is the first graph for this fuselage adsorption isotherm. This is the graph between the amount of adsorbent, that is adsorbed, versus the pressure. Now let's see for a single system only. Now look at this graph. See, it's difficult for me to make it, so let's divide this graph in 3 parts: 1, 2, and after that it is 3. This is first part, this is second part, and this is third part. Obviously this is P, and this over here is X pi. As we know, these pressures over this range, before this point, these pressures P1, P2, P3, P4, P5, P6, P7, P8 up to this, these are low pressures. For this, these are intermediate pressures, and for this range, these are high pressure values. Now look at the graph only for this region 1. I am trying to make it over here. This is X by M and P for this region, for low pressure. See, isn't this a straight line, like a straight line? That means the pressure is directly proportional to the X by M. That means P is directly proportional to the X by M. This directly proportional, I hope you know, this straight line is the graph for the variables which are directly proportional. That means P is directly proportional to the X by M. That means let's make it over here. X by M is, proportionality constant will be there after removing the proportionality, this X by M K P. Now let's take the third part. Now third part of graph is like this. This was our first part, straight line, then it's bit curved, and then it's flat. This portion, this was our third part. As you know, this pressure after which the curve flattens, this is known as saturation pressure. I hope you remember, after increasing pressure, if we take a system and increase pressure, after some time there will be no change in the rate of adsorption. The rate of adsorption will be constant. That means X will not increase. This part is that we are increasing P, but X is not increasing. X remains constant. This, and this pressure correspondingly is known as saturation pressure. As the graph between P and X by M is a constant linear line, that means X by M is directly proportional to the P raised to the power 0, because if we increase pressure, this X by M will not change. That means X by M